Okay, so we are now on day 2 of 2627 proving statements. Today is September 15th. I can see I'm off a little bit on my recording here. We're going to apply complex reasoning to complete multi-step proofs. Complex reasoning is just saying we're using deductive reasoning, and we're going to do multi-step proofs. So we have a couple of definitions. The first one would be proof, because if I expect you to do a multi-step proof, you should probably know what a proof is. A proof is an argument based on deductive reasoning put in a logical order. So an argument doesn't mean you're having, you're not happy with somebody. It's not that kind of argument. It's a debate. Okay, so an argument based on deductive reasoning, so that's your complex reasoning, your deductive reasoning, and it must be in a logical order. You don't defend what you're saying and then go to something backwards and then forwards. You want to be in a logical order. You want somebody to be able to follow your train of thought, and that's what a proof is just showing your train of thought. Now, all of mathematics is logical. You can't do it if there's not a rule. So if they didn't teach you a property or some kind of rule, then you couldn't do it. So you actually have a lot of things in your arsenal already for things that you can justify with. I'm saying the word things a lot. Sorry about that. Okay. So we know we have to know definitions, postulates, theorems, properties, because every one of those will support what you're saying. So if you think about proofs that we're going to do and think about having to cite your source, that's what this is really doing. You're defending what you're saying by citing a source. Your source is going to be that postulate, definition, theorem, property. So the definition we're going to deal with today is perpendicular lines. If two lines intersect to form a right angle, then the lines are perpendicular. So why did I make the A so big? Because I really want you to think about it as one. Okay. So if you have two lines that intersect, we know that they just intersect, they run into each other, they intersect in a point. I mean, we know that from chapter 1. We know if they intersect, they make vertical angles. Well, now there's something else we know. If they intersect in a very specific way, they will also be called perpendicular. So I have a horizontal line, which we will call line L. Remember that lines are lowercase script, and a vertical line, which we'll call line M, lowercase script. And at this point, based on that picture, all I can say is, hey, they intersect. But the moment you see one right angle, and remember that's a right angle mark, now we know they're perpendicular. So line L is perpendicular to line M. So an upside down T is the symbol for is perpendicular to. So that one little symbol is for 3 words. Line L is perpendicular to line M. So now we have a couple of theorems, a couple more things that will justify what we're allowed to do. Now we know that right angles are 90 degrees. But this theorem is about what happens when you compare two right angles. And the most important thing that you need to know about postulates and theorems that we tend to forget is that they are actually statements that are shortcuts. So this theorem says if two angles are right angles, then they are. Well, we don't say then they are 90 degrees, because first off, they aren't. Their measures are, but we're comparing them to each other. So how do they compare to each other? They are congruent to each other. So if two angles are right angles, then they are congruent. Now, how is that a shortcut? Seems like it's really not, but it is. Okay, so here's how it's a shortcut. We know that right angles are 90 degrees. So we know that both angles would be 90. So that means that the two angles would be equal to each other because of the transitive property. And then if they're equal to each other, then we know they're congruent because that's what the definition says. So that's like 4 things. This one theorem takes them straight from right angles to congruent and skips all those other steps. So here's a specific example that would go with this theorem. Angle A and angle B are right angles, so we also know angle A is congruent to angle B. So if two angles are right angles, then we'll also know they're congruent. No matter what their names are, if they're right angles, they're going to be congruent. The second theorem is about those perpendicular lines again. If two lines are perpendicular, what else do we know other than there's one right angle? Because that's the definition, that's not a theorem. So the theorem tells me what else is true, and that is that they form 4 right angles. Okay, so if line P is perpendicular to line Q, we know there's one right angle because that's what the definition of perpendicular says. So what happens to the other angles? Well, this theorem tells me what happens to the other angles. They are right angles as well. So not just the one that we knew about, now all 4 of them are right angles. So this theorem's job is to tell you what happened to the other angles, not that initial right angle. So we have 2 theorems. If two angles are right angles, and if 2 lines are perpendicular, then they form 4 right angles. Okay. So again, today's objective is to apply complex reasoning to complete multiple proofs. So we're going to do deductive reasoning to multiple step arguments. The nice thing is we're going to use what we already learned yesterday. What was the trick to get a specific example into a general example? We took the specifics and we generalized it. If it says angle 3 and 4, we just said, hey, there were 2 angles. Okay, so here was yesterday's. We were shown 2 angles. Who cares what their name is? We don't care. We have 2 angles that formed a linear pair. So if 2 angles form a linear pair, then, and this is where your pronoun comes in, those same 2 angles are now supplementary. So if 2 angles form a linear pair, then they are supplementary, which is a postulate that we learned in chapter 1. So today is still the same exact process, except now it's going to look more like your algebra problems from last week. We want them to be vertical. Okay. So same as above, but the 2 statements that you're given, the 2 specific statements that you will be given, will be vertical, just like an algebra problem, but you're still going to do the same thing. Okay. So how did we get from the first half to the second half? We said, oh, look, there are 2 angles forming a linear pair, and they are supplementary. So if 2 angles form a linear pair, then they are supplementary. And again, it's a postulate that you either needed to memorize or apply this trick to. Okay. Remember, please go back and rewatch any part of the video you want and pause when you need to. It's probably a really, really good idea that you pause this right now. If you have not printed out the notes, you can see how much is already in the notes that you don't want to have to write down. And if you only write down answers and don't have questions, those notes are useless. So please take the time to print them off. You can always find the notes at the bottom of the week, or there's a section called blank notes. Okay, so our first example is use a postulate or theorem to fill in the reason for step B. Now I can either memorize them, go look for them, or I can use the trick. I have two angles, and they are vertical. Again, I don't care what their names are. I have two of them, and they're vertical. So if two angles are vertical angles, please don't say vertical, because vertical is different than vertical angles, then they are what? What does that symbol mean? They are congruent. And that's a theorem from chapter 1. If two angles are vertical angles, then they are congruent. And you can write out the word angle or you can use the symbol. It's completely up to you. Okay. Now, I have to change up just a little bit. For us to truly prepare for future lessons or logical arguments, your reason must go next to the conclusion, just like the steps in an algebraic problem from earlier in the chapter. So remember, we went A got me B, but why? Okay, and we would have done a property. This isn't a property because I'm not going from a measure to a measure. Okay. Now it says it's a definition, so I can either go look up my definitions or I can use the trick. What do I have? I have two angles that are congruent. If two angles are congruent, and you can either spell out the word congruent or you can use the congruent symbol, that's up to you. If two angles are congruent, then what's happening? Then their measures are equal. If two angles are congruent, then their measures are equal. And remember how I said that was a definition? It is. That's the definition of congruent angles. That is the definition of congruent angles. Excuse me. Okay. Oh, by the way, there's one more thing. Remember the hypothesis, that if part? Step A is the given, just like the first step in an algebraic problem from earlier in the chapter. So how do I know that point M is between points L and N? Because I'm giving it to you. But the process is still the same. A gets me, oh, that's supposed to be a B. A gets me B and Y. Now, there is a small problem right here. It says this postulate or theorem is not in if-then form. So not in if-then form would be things like the segment addition postulate, the angle addition postulate, and those 6 theorems that we learned yesterday. If you need to draw a picture, go ahead and do it. We have point L, point N, point M somewhere between. Why would the two smaller measures add up to the bigger measurement of the segment? Because it's the segment addition postulate. Number 4. These together are going to give me B, but why? Okay. So you'll notice we have angle ABC is congruent to angle MNO, and angle MNO is congruent to angle XYZ. So you have 3 actual angles. One is a duplicate, and it's not part of the answer. So it's tying them together. So it's like the transitive property, but these are not measures. They're congruent. So congruence of what? Good. Congruence of angles is transitive. Congruence of angles is transitive. Okay. Before we go on, I just wanted to show you a couple of things because I know it's like your hand's starting to get a cramp and you're like, oh my gosh, how do I have to keep going? So I'm going to show you a couple of different ways to write these things a little less. It's still, I would still use the trick in my mind even if I wrote them shorter. The segment addition postulate can just be called the seg-add-post, segment addition postulate. That's, you would read it segment addition postulate. And then I want you to go all the way back to the top of your notes. Vertical angles are congruent. You will see that statement sometimes, and it is the same as what we wrote. It's just that if you practice the if-then trick, you're more likely to be able to get the correct answer without having to memorize the entire list. Okay, so we still haven't fully gotten to the objective yet. Because again, the objective was to apply complex reasoning to multi-step proofs. So far, we've just done a single step. Or 2 steps if you want to put it that way. Okay, so what we're going to do in today's multi-step proof is we're going to make it real easy. A is still going to go with B. B is now going to go with C, and C is going to go with D. So it's just like the algebra problems that we had before. So let's say we had 3x plus 5 equals 6x plus 9. Sorry, I know it's not in red, so you don't have to write it down. Okay. This would be your A. Then 5 equals 3x plus 9. That would be your B. So A got you B. Then negative 4 equals 3x would be your C. So B got your C. Negative 4 divided by 3 equals x would be D. So C got your D. So you're going to do it just like the algebra problems, except now it's going to be postulates and theorems and definitions that you should know. Okay, so this is an example 0. I do not want you writing this down. I simply want you watching. And I am going to use the trick as much as I can. Okay. So angle A and angle B form a linear pair. Why? Because it was given. So that's already pre-typed in there for you today. Tomorrow it won't be. How do I know then that angle A and B are also supplementary? So A is going to give me B because I had 2 angles that formed a linear pair. So if 2 angles form a linear pair, then They are supplementary. So if you kind of think about it this way, A is if, B is then. You just don't want the specific names, you want generalities and descriptors. So if two angles form a linear pair, then they are supplementary. And now I'm going to totally ignore line A. I don't care about line A anymore. If angles A and B are supplementary, how do I know their measures add up to 90 degrees? Because, again, I'm going to talk in generalities. If two angles are supplementary, okay, sorry about my hand. I'm running into my chair. Okay. So if two angles are supplementary, then their measures add up to 180 degrees. So what we've done is we've started over. This is now if, and this is its corresponding then. Okay? So you just keep starting over. If then, start over. If then, start over. If then, start over. If then. Now, again, I know your hand is getting very tired and you're like, oh my gosh, I have too much to do. Okay, so the short version is linear pair are supplementary, and that still is the postulate. Linear pair are supplementary for B. You can write that instead, but it doesn't help you with the if-then trick. And then C is the definition of supplementary. And again, you can write that, but it doesn't help you with the if-then trick, which I always highly recommend that you use that trick. Okay, so now these are the ones that you're going to do with me. So how do I know that line L is perpendicular to line M? Because it was given to me. I gave it to you. It was given to me, however you want to put that. So A is going to give me B, but why? So what do I have? What are L and M? They're lines. What's true about them? They're perpendicular. If two lines are perpendicular, and you can spell out perpendicular or you can use the symbol. Please don't say if they are perpendicular. Well, who the heck are they? Who are they? I don't know who they are. So if two lines are perpendicular, then what's happening? Well, we're going to transfer from lines to angles. And we have two options. We have the definition which says one angle, and we have the theorem that says 4. Yet I'm only talking about 2. Well, you can't say the 1 because 2's more than 1, but you can say the 4 because even if you're not going to talk about all 4, that's one you want to use. So if two lines are perpendicular, then they form 4 right. Oh, whoops, I've never told you that. The abbreviation for right is just RT, so you can either abbreviate it or you can spell it out. So right angles. Okay. So if two lines are perpendicular, then they form 4 right. Now we're going to go and totally ignore line A. Like, don't look at line A anymore. Don't look at that. We're going to B. How does B give me C? And how do I know those go together? Because they're both talking about angles 1 and 2. Y did that happen like that? What postulate, theorem, definition, why can you do that? And again, use the trick, it makes it easier. I have two angles that are right angles. So if two angles are right angles, then what's true? Then, oh look, they are congruent. Feel free to write out the word angles or write out the words congruent, or you can use symbols, whichever one. I know that your hand's going to get tired, so consider using the symbols. I know some of you are going to look for the shortest way to write these. Again, if you write them shorter, the if-then trick you should probably still be doing in your head. So here is the shorter version. Perpendicular lines form four right angles. Okay, so that's a theorem. It is not the definition of perpendicular, because that would only be one angle, and we have two. And then the second one is all right angles are congruent. And that's the shorter version of that one. So you're more than welcome to use those shorter versions. Please understand that the trick doesn't work very well when you do that. So you might want to consider the trick in your brain. Okay. So our last example is, oh great, there is more than, an A, B, and a C. It's okay. We're still going to do it the same way. How do we know that line L bisects segment XY at R? Because it's given. Now I am going to draw a picture because I think sometimes it's easier to see that. Okay, so that's the picture they're giving us. So if line L bisects segment XY at R, then how do I know that point R is a midpoint? Because, and I'm gonna say things and then I'm gonna write something else. If a line bisects a segment, then it does so at midpoint. Wow, that's wordy. If a line bisects a segment, there is a midpoint. That's still pretty wordy. How do I know either one of those? Because the definition of a segment bisector tells me that. So definition of a segment bisector is the best way to do this one. Definition, DEF, of a segment bisector is the reason why I know point R is a midpoint. Now I can put it in if-then form because I keep telling you, use the trick. This one is not pretty. If a line bisects a segment, then the point is a midpoint. That's what that sentence would have looked like. If a line bisects a segment, then the point is a midpoint. And you can write that if you want. Because that follows the if-then trick. If a line bisects a segment, then the point is a midpoint. Okay, so then we're going to move on. So again, we're going to ignore A. And what does a midpoint tell me? A midpoint tells me that there are two congruent segments. So again, I can put it in if-then form. If a point is a midpoint, then there are two congruent segments. And that is definitely the trick. And it works. But it doesn't work very pretty as well. So this one is definition of a midpoint. Definition of a midpoint. So to get C, I told you to ignore A because we were just doing B to C. To get the next one, we're going to ignore A and B. We're just going to go from C to D. How does C to D work? Like, why is that working? I keep forgetting to write the Y's. You don't have to write the Y. I just keep doing that. Okay. So you'll notice we're using the same exact letters in both, but in C they're segments and in D they're measures. So if two segments are congruent, then what's happening to them? Then their measures are equal. Then their measures are equal. If you want to write that in the short version, this is definition of congruent segments. So I just wanted to point out something else to you so that when you are doing your homework, it might make a little more sense. Because this is supposed to be in a logical order, kind of like a rock rolling down the hill, think about your reasons on the right, your general reasons on the right. Wherever you end with a reason, you should start with a reason. So look up at 1B. It ends with right angles. Where does 1C start? With right angles. Let's go down to 2. Where does 2B end? With midpoint. Read the little red line. Midpoint. It ends with midpoint. So where does C start? With midpoint. Look at the little red. With midpoint. Where does 2C end? It ends with congruent segments. 2C ends with congruent segments. So where does 2D begin? With congruent segments. That's why I am not a fan of writing the short versions, definition of, and I don't like those because then you can't see where you ended and where you should begin. But I am going to tell you that they are all possibilities. You might want to definitely this week, I forgot to mention it yesterday, there is also a file that has the Google Forms in a printable format. So you may want to print these out first, do the assignments on paper, and then go to the actual Google form and answer the questions. It might be easier in this case to do that. Again, please make sure you email your teachers if you have any questions. And don't forget, a week from today, you are taking a test.